move on to our next session on the spectacular FGD installation and implementation journey of Adani Dahanu Power Plant. I would now request Mr. Sucheta Patil, Manager Environment, Adani Dahanu Thermal Power Station, to join us by putting her video on. Ms. Patil has been working as Manager Environment Management Group at Adani Dahanu Thermal Power Station, Adani Electricity, Mumbai, Dahanu, Maharashtra, since 1997. Her expertise includes DM plant operations, coal and oil testing, steam and water parameters, boiler monitoring, and testing. At present, she is working in the Environment Management Group, EMG, and looking after various statutory and legal compliances. During her service, she has worked as assessor for Adani Workplace Management System and has also worked as internal auditor for various ISO systems. She has completed Six Sigma Black Belt training from the Concept Business Excellence. uh, uh, Ms. Patil, requesting you to please turn your video on. Thank you for joining us, but we are unable to hear you.
Can you hear me?
Yes, loud and clear.
Sorry.
Thank you. Thank you for joining us. And I have given you the rights to share your screen. You could share your screen and start the presentation.
Good afternoon and welcome all. Yeah. Is it visible, my presentation?
No, ma'am, we cannot see your presentation yet. You will have to click on the share screen option at the bottom of your screen. Yes, we can see your presentation now. You could go to the slideshow mode.
Okay.
Yes, we can see it now. You may continue.
Okay, thank you. And good afternoon, all of you. Last 2 days, we are discussing on various control measures in thermal power plants for air quality. And today, I will discuss with you the FGD at Adani Dahanu Thermal Power Station.
Ms. Patil, you have stopped your screen sharing.
One second.
Yeah. No problem. You can take your time and just share the screen again. Yes, we can see it now. We can see your PPT now. You could continue.
Okay, sorry.
No problem.
So what is need for flue gas desulfurization system we were discussing for last 2 days. In any coal-based thermal power plant, the main emissions are sulfur dioxide, oxides of nitrogen and particulate matter. It is necessary to control and maintain these emissions below statutory limits because we know these emissions are going into air and polluting our environment and climate. So when we are talking about flue gas desulfurization system, why it is required in power plants, it is to remove sulfur dioxide. So before any norms by MOF or any regulatory authority, in Dahanu Thermal Power Station, we installed this FGD around 2007. Why to remove SO2? SO2 remove is required because sulfur dioxide, we know it is acidic in nature. and then it reacts with water, it forms acid, and in turns it is toxic to human life. Then it causes uh, cough, then creates problem to respiratory tracts. Then because of acid rain, we know it will damage irrigation. Then in turn it will do acidification of seawater. So all these harmful effects we know it is because of sulfur dioxide and nature of sulfur dioxide. Also it contributes the depletion of ozone layer. So we discussed yesterday and today also what are the different types of flue gas desulfurization systems. There are mainly three types of flue gas desulfurization systems, which are dry FGD, flue gas which is brought to saturation temperature, and scrubbing is done at this point. Normally, limestone is injected in the path of the flue gas, and this type of flue gas has some advantages. It is efficient for less sulfur dioxide. Also, it is 99% SO2 is removed through this system. Then dry waste product, then over 99.99% particulate removal. Also, it removes mercury, dioxins, and metals. And there is no stack flue, no sludge processing equipment is required. Disadvantage of this system is insufficient. That is, for removal of 1 kg of SO2 requires around 5 kg of reagent. Then it is also a costly affair. Efficiency is less than 30 to around 30 to 40%. Then other type of FGD is semi-dry FGD. The semi-dry FGD, we use lime, hydrated lime or soda ash, and scrubbing takes place above saturation temperature, as we want dry product at the outlet of the FGD. Advantage of this type of FGD, its efficiency is around 80% to 85%, and byproduct brings in revenues. Also, this type of FGD also has some disadvantages. Byproduct handling unit adds to cost and maintenance. Then another type of FGD with lime, it is wet FGD. In this type of FGD, gas is brought to saturation temperature and scrubbing is done at this point. Reagents used are limestone. Advantage of this FGD are efficiency is around 97%, with 90% pure limestone we have to use. Byproduct gypsum is 90% pure, and most advanced technology. This is the most advanced technology in the market, and very low operation and maintenance expenses. Operation is fully automatic with PLC control. No plugging, scaling or corrosion problem. Zero discharge system available with water recycle. But this system also has one disadvantage. Byproduct handling unit adds to cost and maintenance to the system. Now we will see FGD at Adani Dahanu Thermal Power Station. Adani Dahanu Thermal Power Station has installed FGD since 2007, and by doing this investment, this becomes the leading investor for environment protection as as a FGD. We saw there are different types of methods for removing SO2, and mainly classified as wet method and dry wet method. Looking at the merit and demerits of these both types, at Dahanu Thermal Power Station, we chose wet type FGD because it has more merits over the dry method. The FGD which was installed at Dahanu Thermal Power Station was the first time in India that was used a seawater based FGD, and it installed for 500 megawatt of coal power based thermal power plant. We installed FGD with use of seawater because seawater is an economic source of natural alkalinity, and which was very adjacent and available in abundance for our power plant. The abundance of seawater and alkalinity eliminates requirement of purchases, storage, and handling of expensive reagents and chemicals which are required for FGD. As we discussed, the main important is natural reagent and natural alkalinity of seawater, which is 99% efficient. It does not require any byproduct handling system, no problem of choking. Also, it is low maintenance, low investment, also low power consumption. Then the packing material provides high removal efficiency and low pressure drop. No sludge aerated water discharged to sea, no chemicals required. Seawater pH being between 8 to 8.5 and which is alkaline, and it's used for removal of SO2. Water flows via gravity from scrubber to aeration basin and minimal controls are required. This is flow diagram of FGD at Adani Dahanu Thermal Power Station. Before installation of FGD, the flue gas from boiler is directly discharged through stand. But now we have FGD. So flue gas desulfurization system is accomplished by seawater scrubbing, and each stream of 250 megawatt line has independent stand-alone seawater scrubbing system, and each scrubber is designed for around 10 lakh normal meter cube of per hour of flue gas flow from boiler, and the removal efficiency of SO2 is 90%, more than 90%. The flue gas from boiler first enters into gas to gas heater where it is cooled from 135 degrees to around 92 degrees Celsius by outgoing gases. And in turns, the outgoing gases are heated from 44 degrees to 86 degrees. The GGH is rotary heat exchanger, and it handles large volume of flue gas. From GGH, the water is then taken into scrubber. The subcooled flue gas from GGH enters horizontally at the bottom of the seawater scrubber. This scrubber is square vertical concrete vessel with FRP, GRP, GRE lining designed to withstand long-term contact and corrosive effect of a hot acidic brine. The seawater is sprayed counter current to the flow of flue gas at the top of surface packed bed in order to achieve effective SO2 mass transfer and absorption in liquid base. The seawater is sprayed through specially designed spray nozzles distributed in such a way as to uniformly cover the maximum surface area of packed tower. The packing material is specifically designed packing with very high surface area so that gas to seawater contact optimize at given packing volume. The capture of SO2 in scrubber is several physical and chemical process, being with gas phase concentration and special pressure driven mass transfer across the and optimized liquid phase. Chemical mechanism take over to capture SO2. Hydrolysis, neutralization and oxidation reaction mechanism helps to stabilize the absorbed SO2 and prevent it from escaping the seawater liquid phase and returning back to the flue gas phase. The SO2 in flue gas is absorbed and converted to sulfide. Sulfide is further oxidized to sulfate, which is safe for sea discharge. The CO2 generated generated during neutralization reaction escapes both with reacted flue gas through scrubber outlet and later in oxidation basins by means of air stripping mechanism. The seawater scrubber is drawn from condenser cooling water, which is used for power station. The condenser cooling outlet has capacity to supply enough for the sulfur dioxide absorption and mixing. The scrubber exit water from the bottom of the scrubber flow through GRP-GRE duct and line gravity of mixing basin. The main purpose of this mixing basin is to mix scrubber water, mix this scrubber water from both scrubbers and remaining condenser seawater to bring the pH of the mixed water to minimum of 6.5, because this water is acidic, so we have to raise the pH of this water. The amount of scrubbing water from the scrubber enters the mixing basin below the water surface, so the pH is raised further prior to overflow to the oxidation basin. So this is oxidation basin. The mixing basin volume of the overflow mixing basin is taken adjacent to the oxidation basin, have volume of 8,000 meter cube. After this, in the oxidation basin, the dissolved oxygen of the scrubber water is raised. See, the FGD is the new concept in power industry, and the availability of this FGD, the limit which is given by Pollution Control Board for Dahanu Thermal Power Station was 85%, but because of good preventive measures and operation measures, the availability at Dahanu Thermal Power Station is always more than 90% since inception. So we have seen this chemical reaction which is taking place in scrubber. SO2 in the flue gas reacts with water. The sulfurous acid is formed. Then sulfate ion, which again reacts with the oxygen, and sulfate is formed. So this is all about chemical reaction. Now I will talk about the result and environmental performance. Stack emission SO2 before installation of FGD. You can see the emission values are around 2000, more than 2000 milligram per normal meter cube. And at that time, limit for this SO2 emission was also slightly on higher side, that is 3680. After we have installed flue gas desulfurization system, I have shown you the last 6 years values of SO2. The limit which is given by Ministry of Environment and Forest for this thermal power plant is 600 milligram per nm cube, and we are achieving it around 200 continuously. So we can see how much difference is there, and the good environment performance of this power plant. Again, I want to see one thing. You can see these photographs of birds which are enjoying this water, FGD outlet water. So how it is helpful for environment, and so this is very important, and these are actual photographs from our power plant. So this much from my side. Thank you CE for giving this opportunity.
Thank you. Thank you so much, Miss Patil. I am seeing there's a quick question that's popped in the Q&A box. And to all the attendees, if you have any questions for Miss Patil, please do ask. There is a question from Manoj Kumar Panda. It is observed that emission level has been increasing. Why?
Uh, it is not that much increasing, but now some we have changed our coal blending ratio, so that might be the reason that this emission level is slightly increasing.
Okay, okay. Any other questions from the
Yes,
attendees?
yes, ma'am. Yes, ma'am. I
Yes.
have a question. RK Aneja.
Sir, you could put your video on, please.
Okay, system is not allowing me.
1 second, let
Not
me
allowing
check.
me to. How I can?
Oh, your video is already on, but we are unable to see you. But yes, you can go ahead with your question.
Okay, my question is, how much is the temperature of effluent in the reaction tank? How much is the temperature of effluent and how it is brought down? To bring it down, you use fresh seawater or you use hot water from condenser?
No, we use seawater only, sir.
Fresh seawater.
Fresh seawater, which is coming out of condenser outlet.
Okay, that means you are using hot water.
No, not that is not hot. That the temperature is around 30 to 35 degrees.
What about the temperature of water at inlet to condenser?
Inlet condenser temperature around 30. Suppose it is 30, so outlet is more than that, like 35, 36 degrees.
Let me yes. Then you
Because
use this.
actually is placed at the end of the condenser outlet.
That means you're using the hot water from condenser outlet for bringing
Yeah,
down
but
temperature of effluent.
yeah, but that hot water is cooled down. That is not actually hot water with temperature more than 50 degrees like that.
Is it cooled? Is it cooled down using cooling tower?
Sir, Samir Vore from Dahanu Thermal Power Station, sir. We do have the pre-cooling channel where we actually brought down the temperature of condenser outlet water to a ambient level, and from where we actually brought that water to the scrubber by the use of the seawater pump.
So, are you using cooling tower?
No. Ours is an open loop, open cycle.
So, how do you reduce
One
the temperature of hot water from condenser outlet? How do you reduce it?
We have this 7 kilometer pre-cooling channel is there.
Sir,
Okay.
we have 3.5 kilometer and 120 meter wide pre-cooling channel, which is zigzag cooling channel.
Okay.
Which is designed by CWPRH. So we cooled this condenser cooling water in that channel. We are having one through cooling system at the thermal power station.
Okay.
And we are not using
Okay, ma'am, if I have few more questions, can I email you?
Yes, sir. No problem.
Would you please share your email at the end?
Yes, sir.
Please share.
Mr. Aneja, we'll pass that on to you after this event today.
Thank you.
Yes? Okay. Thank you so much, Ms. Sucheta Patil and your team for this lovely presentation.